Okay, so we're back. Here we are recording. Still week one, experiment two, and so here we are. Here we go. All right. I think it's pretty much all the same equipment, except now we're going to use our cranberry juice and our apple juice and our beaker and our funnel and our water. Okay. You provide the water. Okay. I think you all have access to water. So apple juice, cranberry juice. Here are our juices. You should be in your kit. Cranberry and apple. This is just to emphasize to you that we're using different things. One represents one solution, and the other represents another solution. Okay. It's the same day. You saw me wash my hands and apply my gloves, and so we're going to declare a truce on that. Okay. Hands washed, gloves applied. Okay. We have a 10 mil graduated cylinder. We have our 100 mil graduated cylinder. We have our pipette, cranberry juice, apple juice, 250 mil beaker. Funnel is the funnel. Yeah, funnel's over there. Okay, and we have our water. Okay, all right, all right. We're going to declare arbitrarily that the fruit juices are 100%. Okay, 100% fruit juice. Okay. Parenthetically, cranberry juice cocktail. Okay. You've heard about the health benefits, particularly in terms of urinary tract infections, of cranberry juice. Okay. That refers to cranberry juice. Okay. What you see most frequently, unless you really look for it, what you usually see is cranberry juice cocktail. That's a euphemism for cranberry juice with a lot of sugar added to it, because cranberries are bitter. They're not tasty, okay, by themselves. They have a lot of bitterness to them, and in order to make them drinkable, they add a lot of sugar to it, and that destroys, in terms of urinary tract infections, any health benefits that it might have provided. Okay, because you don't want that sugar finding its way into your urine. It just feeds the bacteria. Okay, so if you find the occasion that you want to use cranberry juice to help you with relief from a urinary tract infection, you want to make sure you read and you're getting cranberry juice, not cranberry juice cocktail. All right, off the subject, but I had it in my hand. I thought I'd talk about it for a minute. All right. So we've washed our hands, we put our gloves on, and again, we're going to put 73 milliliters of water, followed by 25 milliliters of juice into 100 juice A. Now, okay, be careful. Juice A is cranberry. Okay. So here's our 100 milliliter beaker. Okay. We're going to add 73 milliliters of water. In order to do that, I'm going to measure this graduated cylinder. How are we doing? Right. 73. Perfect. All right. 73 milliliters, 100 milliliter beaker. Bum, 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 bum. Okay. Juice A is our cranberry juice. In this case, it's cranberry juice cocktail, but we're calling it 100% cranberry juice just for the sake of our math. And again, like I said, cranberry juice is kind of hard to find. You have to make sure you look for it. 25 ml. All right, so I'm going to open the juice. Not up to 20 yet. We're just past 20. We'll go halfway to 30. Now we're going over, of course. By the way, I noticed last term, if you went over on something, you poured it back into the container. That's not really a good idea because you don't know what pouring it into the graduate contaminated it with. So you really should pour, if you have extra in your graduate that you need to pour, you probably need to just pour it into something else, not back in the original container. All right, so there's our 25. And there we have it. All right, so we got 73 and 25. So we really have 98. We don't have 100, we have 98. It's in a 100 ml beaker. All right. All right. Meniscus on the graduated cylinder. We did that always, anytime you measure anything in a graduated cylinder, lift it up to eye level and look at the meniscus. Okay. Double check your final volume by reading the meniscus in the graduated cylinder. Record for a minute. Double check your final volume by reading the meniscus in the graduated cylinder. Record the percent strength of juice in A. Oh, okay. So you're going to record the percent strength again. All right. So we're going to pour this in here. And it is. It's 98. Okay. So what is it? It's 25 divided by 98. Okay, why they didn't make us go 100 and well, we didn't. Okay, 25 divided by 98, and that gives us a percentage. To do that math, 25 divided by 98, and record that there. All right, fine. Now we're going to take 67 milliliters of juice B, followed by 29 milliliters of juice A. All right, fine. 67 milliliters. So we're just going to get rid of this. Get rid of. Normally call it a mortar. Right now we're going to call this a sink. Okay. There. Okay. $67 milliliters of B, which is apple, and 29 of A. 65, 67. The colors make it more visual. In fact, we're using juices instead. You know, we could have used dyes. But, this is cool. Okay, so we got 67 milliliters of B, which is apple juice. There we have it. Okay, and then we're going to add 29 milliliters of A. There's 30. 29 is going to be right below that. Yeah. Okay, we're going to put that in our beaker. There we have it. So we have 67, and now, okay. Double check the final volume by reading the meniscus in the graduated cylinder. Record the percent strength of juice A and juice B in table 5. All right. And just for fun, we're going to pour this in here. And where are we? Looks like about 95. 29 and 67 would be 96. Okay, yeah, right. Okay. So the strength of juice A is 29 over 96, and the strength of juice B is 67 over 96. And calculate that. That's going to be roughly 29% and 67%. It's going to be, they're both going to be a little bit higher than that because you're not dealing with a denominator of 100. The denominator is only 96. So it's going to be about 30% cranberry and about 70% apple. Okay, but do the math and get the calculations. Okay, all right. Double check your final volume by recording the meniscus in the graduated cylinder. Record the percentage. Right. Okay, fine. Although meniscus can be concave or convex, water in glass forms a concave meniscus. That means the edges of the fluid runs up the side. Okay, so you want to make sure that you're always looking at the bottom. Transfer the solution into a 250 ml beaker and set the solution aside for later use. We may use this later. Okay, transfer the solution into a 250 ml beaker and set the solution aside for later use. So we have this solution now. All right. I'm going to empty my 250 ml beaker. And we'll put this into this. I'll put this into the 250 ml beaker and we'll set it aside. So we have here basically our 70-30 apple and cranberry mixture. All right, put 33 mLs of A and 67 mLs into 100, and 67 mLs of water into a graduated cylinder and record the percent. All right, this is easy. A, cranberry. Okay. 33. Okay. 10, 20, 30. 33. Now A, and did you say 67 of 67 of water? It's even easier. All right, fine. All right, so 67 is the rest of it, so we're just going to go up to 100. Lovely. Okay. So there's our 33 and 67. And record, and you, what's the percentage going to be? Well, it's going to be 33. The total is 100, and 33 of it is cranberry, and so it's going to be 33% cranberry. All right. It also says mix 27 milliliters of solution from step 7. That's the stuff that we put in the 250 ml beaker. 27 milliliters of that solution with 28 mLs of juice B in a graduated cylinder, and record the percent strength and grams of juice A in table 5. Oh boy. Okay. All right. 27 milliliters of the solution from step 7. That's this stuff. Do we not need this for anything before we throw it away? No, we don't. Okay, good. Yeah, we do. Oh, no, we don't. Okay. All right. I'm going to put 27 milliliters of this. There's 30 up there. Okay. It's 27 milliliters solution from step 7 with 28 milliliters of juice B in a graduated cylinder. Of juice B. Well, 27 and 28 would be 55. I'm going up to 55. Okay. Oh, it's mad science. Okay. All right. So remember what we had in solutions in part 7, okay, was 67 of B and 29 of A. Okay, that's what this solution was. Okay, so it's, let me see, B and A. Okay, So it's 67 over 96 is its concentration. We're 33 mLs. Record the percent strength of juice A in table 5. All right, mix 20. Well, juice A. Oh, we did that. Okay, fine. Mix 27 mLs of the solution from step 27, which is 67 over 96. And record the percent strength and grams of juice A. Oh, okay. All right. So the amount of juice A is what we're concerned with. The concentration of it is 29 over 96, and we used 27 milliliters of it, so we're going to multiply that, equals what strength? And what do we have here? 50 times 55. Okay, so you would set up a ratio 29 over 96 times 27 equals X times 55. 27 and 55 are the two volumes. Okay, the concentration of the initial solution is 29 over 96. So what is the concentration in the volume of 55? Solve for that. Okay, so do your 29 times 27 over 96 times 27 over 96. Okay, and then further divide that by 55. And that'll give you the concentration of the juice B. No. Oh, of juice A, right? The concentration of juice A. That's what I thought. Yeah, concentration of juice A. All right. So do that math and get that concentration. Record the percent strength in the grams of juice A. What's the grams? Well, it's the same thing. 20. Well, that'll give you the concentration, and then recognize that your denominator is 55. So 29 times 27 over 96 will give you the grams, and then if you divide that by 55, it gives you the concentration. Okay, so there you go. Okay, so that's experiment 2 for this week. Experiment 3, we're going to do aliquots. I'm sorry, not aliquot. We're going to do allegations, and they're fascinating. So we'll take a look at that. Make sure you look at that in your lab book. I can do them here. I can show them to you, but I'm afraid if I hold the page up to the camera, it's going to be backwards. It's not going to help you much. But I'll go through it to the best of my ability. Okay. See you in a little while.